Hello there, and then welcome to a brand new video. Now, in this video, we are looking at reflection, but specifically, since we wouldn't be able to do everything, we'll just look at reflection over the x-axis or the line y equals 0. But before we go into that, let's look generally at what reflection is. So, with this small note I have here, it says reflection flips over a mirror line, right? So most importantly, let's take note of this keyword over here, a mirror line, and we'll get to know what it is in a bit. The reflected image is the mirror copy of the same size. It has the same size and then the same shape, but just reversed in what orientation. If this is an image, so if this is an object and then this is its reflected copy, right? The size of this image is the same as the size of what this over here. The size of this object is the same as this one size. The same applies here. You see, that is what this is saying. And this line here is what we call the mirror line. So it's just like you standing before a mirror. You are standing here, and then this is the mirror. This is the image you are going to see inside the mirror. Okay. And we are saying its size, your size as you are standing in front of the mirror, is the same as what you see inside the mirror. It's not appearing bigger, neither is it appearing smaller. It's just the same. If it differs, then it is actually not a reflection of what you are. The line of reflection is a perpendicular bisector of the segments joining the object and the image. This here is the object. This here is the image. Now, this line here is what we call the line of what? Reflection, or the mirror line. It is a perpendicular bisector. It simply means that it divides the distance between the object and the image such that the distance from the mirror line to the image is the same as the distance from the object to the mirror line. That is why we say it's a perpendicular bisector. So this is just a little or some tips on reflection. Now let's go to reflection on the x-axis. So talking of reflection over the x-axis, the x-axis is also called the line y equals 0, right? So this here is our x-axis. I hope you do see that. Exactly. This is our x-axis, and we want to reflect a point over it. What that simply means is this here is our mirror line. It is our mirror line. Now, this is a point I want to reflect over here. We are assuming you are standing here, and this is your mirror. So how is it going to be reflected over this mirror line? We are going to look at two ways of doing that. The first one, you just need your ruler. Then the second one, you would have to use a formula. Now, you would have to compare the two and then tell which one best suits you. And then you work with it. So using the ruler, let's look at this point over here. The coordinate of this point, that is -6 and then 5. You see, because it's on x equals -6. There's it over here. Then it is on y equals 5. So to reflect using our ruler, we are going to take our ruler and then you put it on the point. So this is our point here. We are going to put it on the point. Then you measure its distance from the x-axis. So this is my x-axis, and as you can see, I have put my 0 over here. This is my 0 here. So I'll measure its distance to the point. Per my ruler, the distance to the point is 2.5 centimeters. 2.5 centimeters. You then come down. We said that if you are reflecting over the x-axis, you are going to get, if you are reflecting in general, the distance from the mirror line to your object would be the same distance to the image. So if this is 2.5, Then on this same straight line, we are going to measure another 2.5. So this is 0, 1, 2, and then this is where my 2.5 is. I'm going to put the point there. And that will be my reflected point. As simple as that. You see, and what is going to be its coordinate? So it is on the point x equals -6 as well, but this time around it's on y equals -5. I hope you do see the -5. So -5. You see, how did you do it? As I said earlier on, we located where our object was, and this is the mirror line we want to do the reflection on. So what we do is we come and then measure. We measure how far the point is from the mirror line. You see, then with that same measurement, we measure away from the mirror line and locate that point. So you realize over here I had a 2.5, and then I came back here to measure a 2.5 as well. That is the first method. Now the second method has to do with using a formula. The formula says that if you want to reflect over the x-axis, then all you need to do is always maintain the value of x. You see, so we are always maintaining the value of x, and irrespective of the value of y you have, just negate it and locate that point. You see, so always maintain the value of x, do not change it, but irrespective of the value of y you have, negate it. So let's come back to this point we're reflecting here. You see, it was -6, 5. So we should always maintain the value of x. It doesn't change. But then let's negate the value of y. So that means we are going to get a -6, -5. This is the point we are going to get if we reflect this point. So let's just locate that. So it says -6, -5, -6, -5. And that is it over here. You see, that is it over here. And it is just the same point we located when we used the ruler. If you could remember, this point here was the same point we located when we used the ruler. So now that we have understood this, let's take a figure and then try reflecting it over the x-axis to see how that is going to look like. So this is the question I would want us to try. It says we have to locate the point A, B, C with coordinates 1, 2, 3, 5, 4, 1 respectively of the triangle ABC, and then we should reflect it over the line y equals 0. Remember, we said the y equals 0 line is the same as the x-axis. So you are reflecting it over the x-axis as A1, B1, and then C1. So first of all, let's locate our points. A is 1, 2, B is 3, 4, and then C is 4, 1. So this is my graph sheet here, and my unit is what 2 centimeters is to 1 unit. I've labeled my y-axis and then my x-axis. Now what I'm going to do is I'm going to plot out my points. A was 1, 2. So on x-axis I look for 1, on y-axis I look for 2, and then this here is going to be my point. Then I come to B, which is 3, 5. B was 3, 5. So on X, I look for my 3, and I go up to where I have my Y equals 5. Then I just put my point over there. So this is 3, 5. Then the last one, which is 4, 1. So on my X-axis, I look for my 4. My Y-axis, I just go up to 1. And this is where I have that. So we can put their labels there so that they can be seen clearly. So now that we've been able to label, what you are going to do is, they said it's a triangle. So you'd have to join the lines nicely. So I'm joining these lines to bring out my triangle. So this here is my triangle ABC with their coordinates labeled. Now we want to reflect it over our x-axis, you see. And we said there are two methods. So let's just use the formula. If you use the formula, we'll come back and look at, we use the ruler to see if it is really going to be satisfying, you see. So we come back here and then apply the rule. So we say using the rule. And what does the rule say? It says x, for every xy, if you are reflecting over your x-axis, then you just maintain your x value and negate your y value, you see. So it simply means that A, which has the coordinate 1, 2, is going to give us what? A1 with coordinate 1, negative 2, you see. Then B, which also had the coordinate 3, 5, if we reflect it over x-axis, we are going to get B1 with coordinate x being maintained and then y being negated. Then our final one, our C, with coordinates 4, 1, is also going to give us C1 with what? 4 maintained, y negated. So these are the points we are going to plot on our axis, you see. So let's come back here and then plot out those points. We had A1 to be 1, negative 2. So this is my 1, negative 2. I put the point over here. And then we had B1 to be 3, negative 5. So this is my 3. And I'm coming down to the negative 5. This is my point over here. And then my C1 to be 4, negative 1. So this here is my 4. So I'll come down to where I have my negative 1. And this is it over here. You see, then we can join our point. We should label as well. So let me just join the point. And then now I put my labels there. Now let's use the ruler. Or even without using the ruler, let's count the squares and see. So if you really pay attention to the number of squares, realize that we have 1 and then 2 squares here. That is away from A. The same number of squares away from A1. You see, just a square away from C. The same number of squares away from C1. Then for B, we have 1, 2, 3, 4, 5 squares away from B. The same number of squares, that is 1, 2, 3, 4, 5 squares away from B1. You see, so irrespective of the method you use, you should arrive at the same answer. Now, to show that it is really a flip, let me just clean what we have here. And I'm going to flip this over. So I'm just flipping it over. Let me see what is really going to happen. So I'm flipping it over. All right. And then just bring it down. You see, it fits perfectly. You see that? That is an illustration of what? Reflection. You see? And if you have to flip over, so if we move away to the mirror line and then flip again, you see, it is going to fit perfectly into the object, you see. So that is just an illustration of reflection. So basically, this is how we reflect points or objects on the x-axis. So this here is a question you can try on. It says, reflect the quadrilateral PQRS with the vertices P, that is 2, 3, Q, 4, 6, R, 7, 4, and then S, 5, 1. So this ends our lesson on reflection on the x-axis. In our next lesson, we'll be looking at reflection on the y-axis. I do hope this video was helpful. See you in our next video. Bye.